Hello students, I am Shubhashish. Today we are going to learn the new topic, powers and exponents. Have you ever encountered really large numbers and wondered how to make them easier to work with? For example, the population of India in the 2021 census was around 140 crore, and the distance from the Earth to the Sun is about 15 crore kilometers. These numbers are so big that they are hard to read, write, and understand quickly. In science, the speed of light in a vacuum is approximately 30 crore meters per second. Just like these examples, large numbers appear often and writing them out can be tricky. To make things simpler, we use exponents to represent such large numbers more easily. In this lesson, we will learn how exponents help us express repeated multiplication of numbers in a simpler way. For instance, instead of writing 10 into 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 10, we can just write 10 to the power of 8, read as 10 raised to the power of 8. Here, 10 is the base and 8 is the exponent. This is much easier to understand and work with. Learning outcomes. After the completion of this lesson, you will be able to understand how to use exponents to represent large numbers. Learn how to read and write numbers in exponential form. Understand and apply the laws of exponents. Keywords from this lesson: base, exponent, exponential form, laws, multiplication, division, integers, whole numbers, fractions, and power. Before going into the topic, we have gone through words like base, power, and exponent. Now we will understand the meaning of each word. What is an exponent? An exponent is a mathematical operation of repeated multiplication. Exponent is also known as the power of a number, and here it is read as x to the power of n or x raised to the power of n. Exponents can be whole numbers, fractions, and negative numbers. For example, consider 5 into 5 into 5 into 5, which is equal to 5 to the power of 4. Here, we can observe that 5 is multiplied by itself for 4 times. Here 5 is called base and 4 is called exponent or power. Write the base and the exponent in expanded form for each case. 8 to the power of 5. Base is 8. Exponent is 5. And the expanded form is 8 into 8 into 8 into 8 into 8. 8 is multiplied 5 times. Next, 9a whole to the power of 3. 9a is the base and exponent is 3. Expanded form is 9a into 9a into 9a. 5u to the power of 4. 5u is the base, exponent is 4. Expanded form is 5u into 5u into 5u into 5u. P to the power of 5. P is the base, exponent is 5, and the expanded form is P into P into P into P into P. K to the power of 6. K is the base and 6 is the exponent. The expanded form is K into K into K into K into K. To the power of 7. 6 is the base and exponent is 7. 6 into 6 into 6 into 6 into 6 into 6 into 6. Write the exponential form and find the values. The exponential form for 6 into 6 into 6 is 6 to the power of 4. The values for 6 to the power of 4 is 1296. The exponential form for 2 into 2 into 2 into 2 into 2 is 2 to the power of 7. 128 is a value. The exponential form for y into y into y is y cube. The value is nil. Next, the exponential form for a into a into a into a into c into c into c into d into d is a to the power of 4 c to the power of 3 and d to the power of 2. The value is nil again. Next, 3 into 3 into 3 into y into y into y. The exponential form for that is 3 to the power of 3 y cube. The value for that is 3 cube is 27 y cube. Next, a into a into a into 15 times the exponential form a to the power of 15. The value is nil. Next, we have b into b into b, so on n times. The exponential form is b to the power of n and the value is nil. AB into AB into AB into AB into AB. The exponential form is AB whole to the power of 5. The value is nil. Write the following numbers in exponential form using prime factorization. 1296. Prime factorization for 1296 is 2 into 2 into 2 into 2 into 3 into 3 into 3 into 3. Group the same numbers 2 into 2 into 2 into 2 into 3 into 3 into 3 into 3, which is equal to 2 to the power of 4 into 3 to the power of 4. Second one, 2500. Prime factorization for 2500 is 2 into 2 into 5 into 5 into 5 into 5. Group the same numbers 2 into 2 into 5 into 5 into 5 into 5, which is equal to 2 to the power of 2 into 5 to the power of 4. Identify the greater number in each of the following pairs. 3 to the power of 4 or 4 to the power of 3. 3 into 3 into 3 into 3 is equal to 81. 4 into 4 into 4 is equal to 64. 3 to the power of 4 is greater than 4 to the power of 3. Second one, 2 to the power of 5 or 5 to the power of 2. 2 into 2 into 2 into 2 into 2, which is equal to 32. 5 into 5 is equal to 25. So 2 to the power of 5 is greater than 5 to the power of 2. Now we will see how exponents will behave with negative numbers. Note, minus 1 whole to the power of odd number is equal to minus 1. Minus 1 to the power of even number is equal to 1. For better understanding, we will solve some examples. Minus 1 to the power of 5. Minus 1 into minus 1 into minus 1 into minus 1 into minus 1. Minus 1. Next, we have minus 1 whole to the power of 6. Minus 1 into 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 minus 1. One. Minus 4 whole to the power of 4. Minus 4 into minus 4 into minus 4 into minus 4. Into 16 equals to 256. Minus 6 into minus 3 whole cube. Minus 6 into minus 3 into minus 3 into minus 3. Minus 6 into minus 27. Into 6 is 162. Minus 2 whole cube into minus 9 whole cube. Minus 2 into minus 2 into minus 2 into minus 9 into minus 9 into minus 9. Minus 8 into minus 729 is 5832. Now we will learn about laws of exponents. Multiplying powers with the same base. Consider an example. A to the power of 8 into a to the power of 5 equals to a into 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 a to the power of 5 is a into a into a into a into a equals to grouping them a into 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 a to the power of 13, and this is same as a to the power of 8 plus 5. Therefore, a to the power of 8 into a to the power of 5 is equal to a to the power of 13. From above observation, we can say that a to the power of m into a to the power of n is equal to a to the power of m plus n. Where a is any non-zero integer, m and n are integers. Now we will solve some examples. Solve 2 to the power of 5 into 2 to the power of 6. Solution. Given 2 to the power of 5 into 2 to the power of 6. According to the law, when bases are same while multiplying, powers can be added. A to the power of m into a to the power of n is equal to a to the power of m plus n. 2 to the power of 5 into 2 to the power of 6 is equal to 2 to the power of 5 plus 6, which is 2 to the power of 11. Is equal to 2 into 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 2. It's equal to 2048. Solve p to the power of 5 into p to the power of 8. Solution. Given p to the power of 5 into p to the power of 8. According to the law, when bases are same while multiplying, powers can be added. P to the power of 5 into p to the power of 8 is equal to p to the power of 13. Here p is a variable and don't have any value. We can stop here. Dividing powers with the same base. Consider an example. A to the power of 9 by a to the power of 5 is equal to a into 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 a by a into a into a into a into a. Is equal to a into a into a into a. Is equal to a to the power of 4, which is same as a to the power of 9 minus 5. Therefore, a to the power of 9 by a to the power of 5 is equal to a to the power of 9 minus 5. From the above observation, we can say that a to the power of m by a to the power of n is equal to a to the power of m minus n if m is greater than n. Consider an example. A to the power of 3 by a to the power of 7 is equal to a into a into a by a into a into a into a into a into a. Which is equal to 1 by a into a into a into a. Is equal to 1 by a to the power of 4, which is same as 1 by a to the power of 7 minus 3. Therefore, a to the power of 3 by a to the power of 7 is equal to 1 by a to the power of 7 minus 3. From the above observation, we can say that a to the power of m by a to the power of n is equal to 1 by a to the power of n minus m, 1 by a to the power of n minus m if m is greater than n, where a is any non-zero integer, m and n are integers. Now we will solve some examples. Solve 7 to the power of 9 by 7 to the power of 5. Solution. Given 7 to the power of 9 by 7 to the power of 5. According to the law, when bases are same while dividing, powers can be subtracted. A to the power of m by a to the power of n is equal to a to the power of m minus n if m is greater than n. 7 to the power of 9 by 7 to the power of 5 is equal to 7 to the power of 9 minus 5, which is equal to 7 to the power of 4, which is equal to 7 into 7 into 7 into 7, equals to 2401. Solve 3 to the power of 4 by 3 to the power of 14. Solution given 3 to the power of 4 by 3 to the power of 14. According to the law, when bases are same while dividing, powers can be subtracted. A to the power of m by a to the power of n equals to 1 by a to the power of n minus m if m lesser than n. 3 to the power of 4 by 3 to the power of 14 is equal to 1 by 3 to the power of 14 minus 4, which is equal to 1 by 3 to the power of 10. Taking power of a power or exponent of a exponent. Consider an example. A to the power of 5 whole to the power of 4. Solution. Here a to the power of 5 is the base and 4 is the exponent. A to the power of 5 into a to the power of 5 into a to the power of 5 into a to the power of 5. Do you remember, before we have discussed when bases are same while multiplying, powers can be added. A to the power of m into a to the power of n is equal to a to the power of m plus n. So, a to the power of 5 plus 5 plus 5 plus 5 is equal to a to the power of 20, and this is same as a to the power of 5 into 4. Therefore, a to the power of 5 whole to the power of 4 is equal to a to the power of 5 into 4. From the above observation, we can say that a to the power of m whole to the power of n is equal to a to the power of mn. Where a is any non-zero integer, m and n are integers. Now we will solve some examples. Solve 4 to the power of 2 whole to the power of 3. Solution given 4 to the power of 2 whole to the power of 3. According to the law, we can multiply the powers. A to the power of m whole to the power of n is equal to a to the power of mn. So 4 to the power of 2 whole to the power of 3 is equal to 4 to the power of 2 into 3, which is equal to 4 to the power of 6. Is equal to 4 into 4 into 4 into 4 into 4 into 4, which is equal to 16,384. Multiplying powers with the same exponent. Consider an example. A to the power of 5 into b to the power of 5. Your bases are different, but the exponent is same. Equals to a into a into a into a into a into b into b into b into b into b. A into a into a into a into a into b into b into b into b into b is equal to a into b into a into b into a into b into a into b into a into b is equal to a into b whole to the power of 5. Therefore, a to the power of 5 into b to the power of 5 is equal to a into b whole to the power of 5. From above observation, we can say that a to the power of m into b to the power of m is equal to ab whole to the power of m, where a and b are non-zero integers and m is any positive integer. Now we will solve some examples. Solve 3 to the power of 3 into 4 to the power of 3. Solution. Given 3 to the power of 3 into 4 to the power of 3. According to the law, a to the power of m into b to the power of m is equal to ab whole to the power of m. 3 to the power of 3 into 4 to the power of 3 is equal to 3 into 4 whole to the power of 3. Nothing but 12 whole to the power of 3. 12 into 12 into 12, which is equal to 1728. Dividing powers with the same exponents. Consider an example. A to the power of 5 by b to the power of 5 is equal to a into a into a into a into a by b into b into b into b into b equals to a by b into a by b into a by b into a by b into a by b, which is equal to a by b whole to the power of 5. From the above observation, we can say that a to the power of m divided by b to the power of m is equal to a by m by b by m is equal to a by b whole to the power of m. Where a and b are any non-zero integers and m is a whole number. Now we will solve some problems. Expand. Minus 7 by 4 whole to the power of 4. Solution. Given minus 7 by 4 whole to the power of 4. According to the law, a by b whole to the power of m is equal to a to the power of m by b to the power of m. Minus 7 by 4 whole to the power of 4 is equal to minus 7 whole to the power of 4 by 4 to the power of 4, which is equal to minus 7 into minus 7 into minus 7 into minus 7 by 4 into 4 into 4 into 4. Solve. 2 by 3 whole to the power of 5. Solution. Given 2 by 3 whole to the power of 5. According to the law, a to the power of m by b to the power of m is equal to a by b whole to the power of m. 2 by 3 whole to the power of 5 is equal to a to the power of m by b to the power of m. This is equal to 2 into 2 into 2 into 2 into 2 by 3 into 3 into 3 into 3 into 3, which is equal to 32 by 243. Zero exponent. Consider an example. A to the power of 4 by a to the power of 4 is equal to a into a into a into a by a into a into a into a. Equal to 1. From above observation, we can say that a to the power of 0 is equal to 1 for any non-zero integer a. Now tell me, what is 9 to the power of 0 according to law that is equal to 1? Negative exponent. A to the power of minus n is equal to 1 by a to the power of n for any non-zero integer a and any integer n. Now tell me, what is 10 to the power of minus 9 according to law, that is equal to 1 by 10 to the power of 9? Points to remember. An exponent is a mathematical operation of repeated multiplication. A to the power of m into a to the power of n is equal to a to the power of m plus n. A to the power of m by a to the power of n is equal to a to the power of m minus n if m is greater than n. A to the power of m by a to the power of n is equal to 1 by a to the power of n minus m if m is lesser than n. A to the power of m whole to the power of n is equal to a to the power of mn. A to the power of m into b to the power of m is equal to ab whole to the power of m. A to the power of m divided by b to the power of m is equal to a to the power of m by b to the power of m is equal to a by b whole to the power of m. A to the power of 0 is equal to 1. A to the power of minus n is equal to 1 by a to the power of n. For any non-zero integers a and b and whole numbers m and n.